So yesterday we did that big 1982 hand portable. Today we're going to do the Jesan KR200. This will be one that's come off eBay, and it'll be about 15 years since we bought it, and I won't have opened the box previously. So I can't remember whether it's an old heap of junk that's incomplete, or as new, or what. So we've got a decent mic with it, we've got the bracket, we haven't got the thumb screws, we have the on the radio, no instruction book. So these radios can get quite rusty, and this is not rusty. It does rattle. Mr. Chippy thinks it looks like a disco. So I wonder what's happened inside. I remember these not being that good. That's something and I know we've covered it before. We get a generous speaker. So what's rattling? Okay. Well, can't think where that's from. Now I'm bound to have the circuit on files, so I know we've covered it before. Swr C2078 for the output transistor. Unit N-type power lead. And it's originally come from a shop called Good Buddies at 15 Derby Road, Sandiacre, which is Nottingham. So distributed by Kernow, and these were about 1987. I'm going to take the lid off because I'm curious to what it says on the printed circuit board. There's a spring washer as well. There's something missing, isn't there? I was looking at the transistors and things on heat sinks just to make sure it's not those with the missing whatever. And there's a screw to go with it. I just don't get that. It just doesn't even fit in with... I can't see anything missing. I'm glad we didn't switch it on without taking the lid off. So it's M129 AF06. It's had some soldering around the synthesizer, which isn't ideal. Oh, it's one of those. It's an MC145106. So it's a multi-crystal mixer. So it's one of those sets where you have to set the 10.24, then set the transmit frequency, and then set the receive frequency with a marker oscillator. So not everybody can do these. No, I can't see anything missing. Well, what we're going to have to do is to... I wonder if we could either go and find a Uniden lead. On the other hand, we can use the crocodile clips to just connect up. Especially if we know which is positive and negative. Well, if it's a grounded chassis, that's one way we can find out. So what I've done, I've gone onto one of the it's a floating chassis. I've gone onto an earth point. And we've got on that pin, so presumably the one apart set on its own is going to be positive. I'll make sure the current limit is switched on with the power supply, and that limits at about 300 milliamps. I've connected the wrong set of crocodile clips. There we are, we're lit up. So I'll just put some more power on it, and we'll take the power supply up to 13.8 volts as well. So connect it to the test equipment. There's the speaker. And this is a made in Korea set. It isn't Maxon. So we have a receive FM hiss. So make sure they're at full. We want delta 2 to be in the centre. What's the centre? About there. Right, here goes. We'll select picture in picture, and on the 3 watt scale we're going to transmit. So full scale deflection would be 3 watts, and it's nowhere near. So are we on high power or low power? Well, that's low power, just 500 milliwatts, and that's high power, which is just 1.6 watts. However, we're current limiting. There we are, that's better. So now I've taken the current limit off the power supply. I normally have it set for 1.2 amps, and it's 1.21, that's why it was current limiting. And we're doing 3.3 watts. On low power, doing 500 milliwatts. I've got a sneaking suspicion the difference between the KR200 and the KR202 is the synthesizer. So we're going to need to set 10.24 first. And 10.24 is the first one there. So if I connect up, well, we'll probably do it easier with the small oscilloscope. I need to print off the circuit because I'm going to need to know what pin the 10.24 reference goes in at. So I'll just pause the video. So luckily we've got a copy of the instruction book on file, and even more luckily there is a circuit diagram in the back. So we know how to work it. Antenna warning indicator. I didn't see a specification, did you? Oh, it's there at the front. 1 microvolt for 10 decibels. Cyanide, yeah. Can believe that. It says transmitter 4 watts maximum. That doesn't mean it does do 4 watts. So looking between pins 11 and 12 is where we should have our 10.24. I think that's where we're going to need to start to look. So I'm going to set up the little oscilloscope. Doing that so that we can see it on the bench. If we pick ourselves an earth up there, let's say pin 11 or 12. So let's be clear, we're looking for 10.24. First thing we need to do, pin 11 or 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Not there, pin 12. 2, 3, 4, 5, 6, 7, 8, 9. 11, 12. Perhaps it's between 11 and 12. I think we're going to have to look up for a reference for the chip, so pause the video. What I've done is to find the KR200 circuit, and it turns out this has an MC145106, So hopefully we can see where the 10.24 crystal goes in, and it now looks like it's between pins 3 and 4. So let's see what happens. No, I'm not sure why we're not getting anything there. Let's try it that way. Okay, so now there we have it. So it's 10.2389. So we need to adjust the trimmer for 10.24. So it looks like the nearest we can get it is 10.2396. So that's not ideal. Okay, but that's where we are, 10.2396. So if we key up now into the test set, should be able to turn this off now. We've got 2779083, so it's slightly down, which is what you'd expect. So I'm just trying to work which the crystal trimmer is for transmit. Well, we'll just adjust the first one we see. Let's put this onto the frequency counter so you can see what I'm doing. So that's your transmit one. I have it slightly high because it dropped with age. And now we need to be absolutely meticulous on the receive frequency. So on the signal generator, 2779125 I want. So that's where we are. So on the second signal generator, so we'll get the cheap Chinese one back out. I want 10.695, which is it should boot up with. .695. So we now put the main signal generator to no tone, and then we'll turn up the volume on the radio, and we've got a musical note. So we know this is 10.695. We know the signal generator is 2779125. So the only variable is now the mixer crystal in the radio. So we need to null that. So you see we had the musical note, and we can go either side. So we now know the radio is spot on frequency on receive too. So that's the hard bit done. Now, the fact it won't quite do 10.24 is near enough, but in reality it could make the receiver lopsided and sound strange, but in reality I don't think that's going to happen, it's so close. So we'll go down the transmit line if I know where I've put my notes. So it should be T9, 10, 11, 12, and then I need to go to a church and do an organ job. As ever, we're stuck with a radio where not all the callers are labelled. 9, 10, 11, 12. So we're going to transmit. Put the other meter back on. Are we on low power? We are. Change that. Peak. 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 RV6 could be a power control, it could be for the low power feature, or it could be in general, or it could even be for the RF meter. It doesn't actually correspond to the circuit diagram at all, this. You've got to make this up as you go along. I reckon that's what I'm looking for. Let's check it in low power mode. That's going to be deviation. Don't know what that is. Probably squelch. These are probably a meter. Doesn't matter what I adjust, nothing happens. So we're at 3.5 watts. I think that's meter. No idea. No idea. No idea. Deviation, I think. So it looks like we're going to have to adjust that one, and that's our only preset left. So not unlike modern radios, it does 3.5 watts. That is 3.5 watts. So deviation, I would expect, is that one down there. I have to draw a silly little diagram, and it will be silly. So we've got a choke there, we've got preset there, we've got a preset there, we've got the heatsink comes round, and a power resistor, got a preset there, and then by the phase lock loop chip we've got one there, which I'm sure is going to be deviation, and then we've got a receive IF, I think it is, and that's probably preset squelch. So we've got 1, 2, 3, 4, 5, 6 as I can see. So let's go for that deviation. Wallow, wallow. suspect it's that. It isn't. It's that. Wallow, that's it. So I wonder if that is a 0 to the delta tune it's got. I reckon it is. I think we'll get back this. Now let's switch the delta tune on. Well, I can't see that's doing any difference either. Right, we'll switch it off. So what about the transmit meter? So I've got a full set of bars. It's going to be one of those two at the back, I'm absolutely sure. Ain't that one. Yeah, I'm not sure where this set's coming from. Let's put it to low power and see what we get. It's not that one. Not that one. This might be one of the first of the fake meter sets. No, it does absolutely nothing. Because it's variable within the SWR calibrate, you just turn it to where you want it, don't you? How does reflect work then? If that's SWR calibrate, it's here. I mean, no wonder we're confused. That's SWR, which is going to be correct. So that's why we're not getting a reading. So isn't that one? It's that one. Okay. Excellent. So that one is RF meter. So we'll move on to receive. We're doing 3.5 watts. We've got the deviation right. We've got the meter showing where we want it to be. I say it's a real fumble around a set like that when the circuit diagram doesn't match up. and the other one doesn't either, so okay. If any of you got a KR200 circuit diagram that covers the MC145106 chip instead of the LC7137, do tell me. So it's receiving, and at the moment, let's see what it's receiving at. It looks pretty good, to be honest. Sensitivity wise anyway. It's doing 0.6 microvolts for 12 decibels cyanide, which is better than what it's expecting according to the book. So let's drop that so we've got about 6 dB on the cyanide meter, and it helps if we show you the cyanide meter. I'll tell you what we'll do, we'll set the detector first. Let's put this oscilloscope on and turn the light off. Put an S9 signal on the radio, which is 100 microvolts for CB in the UK, and then look for some candidates of what's going to be the correct coil. Well, that stands out to me just there, so let's see what happens. We've got ourselves a reasonable waveform there, and we're trying to get that to maximum. I've changed my mind, I think it's that one. And that's nice and more or less sinusoidal, in other words, equal on both. As you can see, we can make it none. So there we go. Way! As I take the pressure off, must not to put any pressure on. There we go. Now go down that cyanide. So I'd expect this is going to be the front end. The biggest signal on for that one. So all that time I spent studying the circuit diagram to make my notes is all through the window. Okay, let's see what we've got now. We've got 0.55, so we've made a little tiny improvement there. 0.55 microvolts. So we'll go back and put S9 on it, and then we'll see what that meter says. No idea. So that's not the meter. Perhaps that's SWR. I'd expect that. Oh, hang on, that was deviation. Won't touch that. That is going to be. What's that? That's it. That's the S meter. Well, didn't expect that. So is that one going to be squelch? Let's turn the squelch up. Turn that down to 10 decibels. Turn the squelch to full. See where that comes in. And it's coming in at 300 microvolts. Let's see whether that preset affects the squelch. No, it doesn't. See if it's not going to be that one. Just get it on the edge of squelch operation. So I'm right on the edge. Yes, it is squelch. So I caught it out. It doesn't have much variation, that's the trick here. So it wants to be at the other end. That's as good as we're going to get it. So we'll drop the squelch off on the radio, turn the signal generator to standby, squelch to threshold, signal generator on. Let's see where it comes in. Oh, it's lousy. Let's try that again in case I've got it wrong. So that's threshold. It's nearly 10 microvolts of sensitivity. It's atrocious. So, you know, you do something like scratch your corner, we'll probably miss the call and have to turn the squelch down. And on an FM radio, squelch is so important. So, I'm sure that's Delta Tune. And that's going to have to be SWR meter. So let's have a look at that. So we'll flick it to SWR and key up. See what happens when we adjust that. Okay, so I'm just going to put it in calibrate. So that's in calibrate. We'll key it up in low power and see whether we can get an SWR. I'll unplug the aerial. No. No. I'll have to get an antenna matcher onto that. So that's all that's left to do. I'm going to have to go and do a church job. And I'll be back and we'll just finish that off. Couldn't resist doing this. The target meter happened to have a patch lead on it. So let's see how many watts we get out of it. Oh look, we get good. We get 4.8, nearly 5 watts out of it, which is quite good because it's actually doing 3.4. Now here's an experiment. When I use the dummy load I made, I wonder what we get then. Just about the same. So with that, I wanted an antenna matcher. That was the plan. So we can make the SWR worse. Which one's which? That's radio. So I can make sure this SWR thing's right. Now, out of interest, what does this meter read? So matcher off, power 5 watts. Oh, meter sticks does it? No, that's what it reads. It says 5.5 watts. It's worse than the Zitagi. So set. The SWR is 1.4 into the dummy load. Oh, whatever it says. Right, switch the matcher on and unmatch it. So we'll match it on that one. And we'll take it to there. So I want to see what the SWR meter is going to read now, because we've now got 2.5 to 1 SWR. So calibrate. There's our calibrate point, and SWR says 2. So does that mean 2 to 1 or 1.2? Let's fiddle with that preset, which we believe to be to do with SWR. No, it isn't, you know. Haven't got the foggiest. I'll try and look at the circuit diagram, which is not very helpful. And if this is supposed to have an antenna, and yeah, it does have an antenna warning indicator. I'm going to make the SWR even worse. See whether that's the antenna warning indicator. Yes, it is. That's what the preset is. It's AWI. So can you see now when I press transmit, it's coming up with AWI, and if I now correct the SWR, so 1.5, we no longer have the AWI on. So there we are, that's found out what that is. I knew it was going to be something to do with SWR because there's a small choke nearby, a little transformer. So that's got that set up. I don't often see those work, especially on Midlands. I reckon we're done. So we'll put that away, we'll put the Zitagi lyometer away. So, having looked at the presets, and this has been a right muddle trying to work out what's what. I'll probably never see another of these again, except if I've got one in a box of junk that I bought. I wouldn't expect a customer to send in a set like this. So, AWI, RF meter, S meter, squelch, deviation, and that's going to be delta tune. And although I couldn't really hear much difference, there was a difference. And the reason I'm saying that it's delta tune, when we look at the circuit diagram, and I know this isn't quite the right set, but it's somewhere near. Take that picture off and press the right button. So what I'm looking at here that one, and it's messing with the synthesizer through that variactor diode. I nearly said varicap, and I also didn't say varactor at the same time. Varicap diode or variactor diode. So that is shifting it very slightly, and of course it only does that on receive. Of course it does. Otherwise it'd be transmitting on frequency, and that would really go down with Busby. Hey, how about that? Let's call the powers that be in this country Busby. And people who are older than me will know what that refers to. In days gone by, the post office used to do the telephones before it was British Telecom. and like a lot of countries, the post office were in charge, and their interference department was the Radio Investigation Service, which happened to be my initials, RIS. I could have a van with RIS down the side of it, full of aerials like I do, and put the fear of God at people driving up and down the road. But anyway, at the time, I haven't had a television for 20 years, and I think it's just about before British Telecom was privatised, about 1984. In fact, I think CB killed this advert off. It got taken over by British Telecom, and it became part of British Telecom. So the local television, the television in this country, were advertising telephones, dial more numbers and spend more money with British Telecom, you know. And it was a little bird, a little yellow bird, called Busby. And while the CB magazines, because this is before CB was legal, and of course if people were caught with an illegal CB, then the Radio Investigation Service would be round. And so he'd been busted by Busby because it was part of British Telecom, part of the post office. So, well, the magazines at the time, there were magazines before CB was legal, and my friend Mark has a collection of every magazine ever. So he's shown me these, and you got cartoons, you know, and they'll be taking the Michael out. We were going to have 928 meg CB in this country. We ended up with 934, and then in the mid-90s that got cancelled. But we were going to have 928, and because it was going to fry your eyeballs, 8 watts of 928 megs was going to fry your eyeballs, and everybody was scared. And you know, so it'd be. I remember a cartoon. Somebody's directed a 928 meg dish at Busby, and it's now fried Busby. You know, things like that. It was quite amusing. I must dig out some adverts of the time, some cartoons from those magazines at the time. So there we are. I think we're done. I say it was a bit of a muddly way through because we're not doing well with the circuit diagram, but we got there. You see, the correct service diagram, although this is probably the right circuit diagram, the component numbers are different on this model to what that's intended for, but it's the same circuit by the looks of it. So the correct one, the correct circuit from the book, is the same apart from the synthesizer. But you know, you can't read all the component numbers because the components are over them, you know, so there's no layout. But I mean, any circuit's better than no circuit. So there we are, Jesan KR200, from about 1985, 1987, that era, and it was one of the also ran brands that weren't that impressive. I still don't know where the screw came from, but we've got it working. So what we're going to do, put it together, and pop it on an aerial, and see if we can hear any bad or good kind of buddies out there. Right, so we're back. We better put the camera back where it belongs. So we've got it back together. As Mr. Chippy says, it all looks very impressive, but so they're up. Concentric squelch. Turn the squelch down. 19 Roger. Right, well, there's nothing to hear on there. So it's on-off volume squelch, mic gain, RF gain, SWR calibration and delta tune. And then we've got dim or bright. I can't see anything dimming there. Okay. 4 watt, 0.4 watt, channel 9, noise blanker, and public address facility. So there we are, the Jesan KR200. Thanks for watching.